Statman here to bring you Chapter 11, Day 2 of the chi-square test of significance. This is for the independence test, and so this is pretty cool stuff. So this is Day 2. It's a two-pager. Pretty easy. We're going to go through some Desmos as well. So I definitely have to bring up Desmos. I'll get that ready over here. There we go. Okay, go to yeah. Okay, so I got Desmos ready. Okay, here we go. So starting with the notes here. So this is when you have at least a 2 by 2 table. Remember, if you have a one by like a one row or one column of information, that is a chi-square test of um, goodness of fit. So this is for independence or homogeneity. They have two different names, but the same exact math. We've gone over that in the previous lesson. So let's try this one. So you got to have at least a 2 by 2 table on this. All right. So here's the general first words of the null hypothesis are there is no association. So like, and then HA says there is an association. So if you think about it, if there's no association between like wearing glasses and intelligence, then the scores between people with glasses and without would be the same because there's no association. If there is an association, then people with glasses would score higher or something like that. So that's where those phrases come in. All right, we know the conditions, the spin rule. Remember, the n in spin is for the expected counts. Usually, all the expected counts are bigger than 5. Once in a while, there'll be one that's not bigger, and then you're going to check to see if at least 80% of those are bigger. Okay. The test statistic is the chi-square sum. Remember, the individual contributions for the chi-square are O minus E squared divided by E. The degrees of freedom is a little bit different. It's the how many rows minus 1 multiplied by how many columns minus 1. So a 2 by 2 table will be 2 minus 1 times 2 minus 1. So the degrees of freedom is actually 1. And the p-value will be on Desmos. And if you were to do it individually, remember chi-squa dist, and then put the degrees of freedom, and you can figure out that. And we're going to do all that for you. Conclusions, same as always, reject or fail to reject. You guys got all that. All right, so this is going to be our first prompt. This is actually going to be the only prompt of the day with this. We're going to do two different ways. This is really cool stuff. Some of this is beautiful math. So is gender independent of political party? Okay. Chi-square test of independence. So we got males and females in our sample, some Democrats, some Republican. Typically, you see more males that are Republicans and more females that are Democrats. Typically, that's the stereotype. Everybody's different. But let's talk about how to get the expected values. Okay. The expected values will be done automatically on Desmos, but you should know how to do them for multiple choice purposes. So here's how you do it. So I have an example up here. So for this one, the 51, you're going to take the number, the column total, 125, multiply it by the table total, 110, and then divide it by, sorry, by the row total, and then divide it by the table total. So 125 times 110 divided by 255, and that's demonstrated right here. So this one, this female one that's 60, it would be 130 times 110 divided by 255. That's all right here, observed and expected. And you should write those in the table because you're going to make the statement in the conditions that all the expecteds are bigger than 5. So you got to have it written down somewhere. Okay. So here we go. Let's run it as a chi-square test. Here is HO. There is no association between gender and political party preference. And then HA, there is an association between gender and political party preference. Okay. Conditions, you guys know these. Representative sample, 10 times the sample size. The sample size total was 255. So there's more than 2,550 people are in the population. The choices are independent, and then all the expecteds are bigger than 5. I wrote them down here, so there's proof of that. Okay. Otherwise, you got to list them somewhere. Now, The degrees of freedom is 1, 2 minus 1 times 2 minus 1, and the p-value is going to be 0.321. Let's bring in Desmos now, and let's go through how to do this, okay? So here's Desmos. And as you know, we're going to start with the word inference, okay? And then we're going to go chi-square test for independence. And then we're going to type in the observed data. And what's great about this, of course, is it does the expected data for you, which is pretty awesome. 75 and 70. And then you click create test, and you can click on the expected values. You can put the contributions. They put little like bars to how big the contributions are. And you can click on the totals if you want. So you got all that. So there that is. It's pretty easy, huh? And you should know how to do O minus E squared divided by E individually. You would do O minus E squared divided by E on 4 of these, add them together, and then turn it into a p-value, okay? And then if you run the significance test itself, this is very skewed to the right because remember, degrees of freedom 1 will be extremely skewed to the right. And then as degrees of freedom rises, it gets a little less skewed, something that could pop up again on multiple choice. So there's your chi-square sum, 0.984, very small, which generates a large p-value of 0.321. And of course, that means a fail to reject, which if I move this back over, you will see that that's definitely a fail to reject HO. I put O1, doesn't even matter. We have insufficient evidence to suggest that there's an association between gender and political party. Okay, great. Pretty cool. Now let's go back to Desmos. And let me remind you, in case you had a multiple choice question, let's check out this chi-square sum 0.984. If you were asked to change this to a p-value, and that's all the information you had, you would type in chi-squa dist, and then you put the degrees of freedom as 1, and then you would go to the right because everything's everything's shading is all on the right, and then type in 0.984, and there you get the p-value. Okay, so in case that pops up for you, okay. All right, so there's that. Now this is going to be cool. I'm going to go back to the last chapter now. When you have a 2 by 2 table like we have here, you can also do this as a proportion test. It's the only time that you can run a 2-prop z-test and a chi-square test at the same time as the 2 by 2 table. And I'm going to do this through the eyes of the Democratic Party. So the percentage of males that's Democrat in the table is 50 out of 125, which is like 40%. And the percentage of females that are Democrat is 60 out of 130, which is like 46%. Are those significantly different? This is going to be cool. Watch this. This has happened on the AP test where they have a table like that and they tell you that you can do this 2 different ways. Okay. So when you run this as a proportion test, check it out. I'm going to do pi 1 equals pi 2, and pi 1 is not equal to pi 2, where pi 1 is the true proportion of male Democrats and pi 2 is the true proportion of female Democrats. So remember the conditions, representative sample, 10 times is here, independent political choice. And remember, you got to have these, all the fractions have to be, NP's got to be bigger than 10 and NQ's got to be bigger than 10. So that comes down to 50, 75, 60, and 70. All the numbers in the table have to be bigger than 10, and they are. So that will give us the central limit theorem ensuring normality. Now, watch this. This is really cool. Okay. So I'm going to run this test. So I'm going to go back into here and I'm going to type in inference. Okay. And I'm going to run a 2-prop z. Okay. And the first successes is 50 out of 125. And the second sample is 60 out of 130. Okay. When you create the test, you got to make it I'll do a significance test, and you got to do it 2-sided and check it out. It's the exact same p-value, but it's a normal curve. And if you think about it logically, it has to be the same p-value. This and this have to be the same, or you'd have invalid math. You can't have the same table producing two different p-values. So one is skewed to the right, and one is a two-sided one that's a normal curve, and they had the exact same p-value because they really asked the same question. It's pretty cool. It's the only time a two by two table can also be a two prop test. So keep that in mind. That has come up before um, on the AP test. Okay, so that's a cool little review for you. So that's why you end up with this stuff. And I got a lot of writing in a small area here, but two props Z, zero goes in the middle. It was 46% and 40. The difference is 0.6. And then you got a Z score of 0.992 or negative 0.992, depending on which way you did it. And then the p-value is 0.321. Failed to reject still. Not great. So that is chapter 11, day 2 of the chi-square test for independence. Go get him, Stat Nation.